Welcome back to ajspeller.com. In today's tutorial, we're going to work with a related rates problem. It's the sliding ladder problem, and we're going to use an online graphing tool to model this problem. So here we have a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is sliding away from the wall at a constant rate of 2 feet per second. We need to figure out how fast is the top of the ladder moving down the wall when the base of the ladder is 7 feet, 15 feet, and 24 feet from the wall. We've already done the analytics here, but as I scroll down, I have a concise list that I've created based off of what we've done by hand and in other previous tutorials on this subject. So here we have 3 different snapshots when the base is 7 feet, 15 feet, and 24 feet from the wall. We have the different velocities at the top of the ladder is moving. We have the parametric equations that we've used in this problem, and we figured out at what time the base is 7 feet away, the time at which the base is 15 feet away, and the time at which the base is 24 feet away. And finally, we figured out the time in which it takes this whole model to run through one cycle where the ladder actually falls completely to the ground. All right, so we're going to implement this information into this model. All right, here remember that the L slider here stands for the ladder, and the ladder has to be 25 feet long. The D is for dx dt, which is the constant rate at which the bottom of the ladder here is moving. That there is set at 2. So we'll slide that over. And then we have a calculation here, which is the length of the ladder divided by the rate at which the bottom is moving, and that came out to be 12.5. So we need to update this here so that the time goes from 0 to 12.5. All right, and if you've been watching, you know that our model here has been moving accordingly. So what we want to do now is we have these times. So we're going to figure out what at the time 3.5 when we're 7 feet away, we want to verify that the velocity at which the top of the ladder moving is negative 7/12 feet per second. So here for time, we're going to move this back to 3.5. All right, when it's at 3.5, we see that we are 7 feet away, because here we are at 5, 6, 7, and we see that the height is the y value is 24. And again, we have that here. The x value is 7 feet away, and the height of the ladder is 24. All right, and let's scroll down so that we can see what our expression for the derivative looks like. And we see this came out to be the negative 0.5833. And you see I already placed in the negative 7/12, and we see its decimal equivalent does match that exactly. Next, we had to figure out when the bottom of the ladder was 15 feet away, and let's go back and get that time. Here we see that happens at time 7.5 seconds. So let's come up here to the timer, to the time slider, and let's move that over to 7.5. All right, here at 7.5, we see that the rate here is the negative 1.5. We also see that the x value is at 15 and the y value is at 20. So let's go back and take a look. X is at 15, the y value is at 20, and we see by hand we came up with negative 3/2. So let's type in negative 3/2 to make sure that's equivalent. All right, so we've got the negative, that's the 3, and then the halves, and we see that that is in fact negative 1.5. And now let's slide back over and get the last one here. Here at time 12, the x, or the bottom of the ladder, should be at 24 feet away. The top of the ladder should be 7 feet from the ground going up. All right, so let's put that in place. We're going to set t to 12. All right, here we are at 12. We see that the rate that we have here is negative 6.857, etc. We also see that we're at 24, and we see the x value is at 24. We see the y value is at 7. And then let's go ahead and grab the fraction from the other screen, and we're going to type that in to get the decimal equivalent. All right, here we see the fraction is the negative 48 sevenths. So let's type that in. So we've got the negative is already there. So let's type in 48 divided by 7. And we see that both of these values here do match. So we verified all of our analytical work. All right, so that sums up another tutorial by ajspeller.com. I want to thank you again for watching and have a good evening.